Hello, friends, students, and enthusiasts. Welcome back once again. So I have one more project presentation for you. Let's go and check it out. What is that project? So the name of the project is Building an Energy Efficient Smart Greenhouse with ESP32. So this guide will walk you through to create a smart greenhouse system using ESP32 microcontroller or microcontroller board. IoT sensors, of course, it is an IoT project. So IoT sensors and automation to optimize plant growth while sort of conserving less energy. So why less energy and why the energy is important here? Why? Because we are using a solar system. All right. So again, what is the overview? Let's see the overview. The smart greenhouse will monitor environmental condition, that is, whatever environmental condition is there, which we are getting from that the sensors like temperature, humidity, light, soil, moisture. Automatically control ventilation, that is, there is a fan or there is a ventilator which will start automatically. Irrigation, of course, irrigation, there is a water irrigation, so automatically the water irrigation will also start. And optimize energy usage with smart scheduling. We can schedule it also. Solar power provide and remote monitoring also. That is smart scheduling and solar power, because both the things for power consumption and power usage, we use solar power here. Okay, that means to consume to have a substantial, or rather we should have alternate for power. So provides remote monitoring via web mobile internet. So we can see or we can control through web dashboard also. Okay, so required components here: ESP32 development board, main controller, DST11 or BME280 temperature and humidity sensor. Either you can use 11 or BME280, but here in my case, we have used DST11. Soil moisture sensor, captive recommended, but or otherwise you can use another soil moisture sensor also, whichever soil moisture sensor present with you. BH750 or similar light intensity module you can use, or a simple LDR. You can connect it to the pins, and one end will go to supply and another one through 4.7K you have to ground it. Okay, 5-volt relay module. In my case, I've not used 5-volt. Only one case I've used one 5-volt relay, and another case I just wanted to show you with the LED light. Right? Okay. Small water pump for irrigation, of course, and micro servo motor for ventilator or some fan for ventilator. 12-volt DC fan should be there. Solar panel you should have, and battery with the charging controllers. So these are the requirements for your component requirement for your project. How does it work? Now listen carefully. LDR measures light, of course. Low value, dark, high value is equal to bright. Okay, that is dark. It will be what? Low value will be dark value. High value is brighter value. Okay, DST22 monitors temperature and humidity. Soil sensor detect dryness, that is whether irrigation is required or not. Pump turn on if soil is dry, automatic. Okay, fan turns on if temperature is too high. That means we have given a threshold temperature there. User can silence the alarm, but it will re-trigger if condition persist. So that is all present in the dashboard. What is there in the dashboard? As access via ESP32 IP, a web dashboard. That means you will get an IP address, and if you log into that IP address, shows real-time sensor data, one manual on-off control and pump fan. That is, two controls will be there. That is one for fan and one for pump. Can be manually silenced, or it can be manually operated. Right? Circuit connection, very simple. Very simple. That is, one side it is component, and the other side it is the ESP32 pins. So DST11 is connected to GPIO4. LDR is connected to GPIO34. Soil moisture is connected to 36. Relay pump, that is relay, is connected to pin number 23. And relay fan, that is one more relay, is connected to pin number 8. So likewise, we have only connected this much of, that is 3 sensors and 2 output relays. Likewise. So in one case, I told you that I have not used a relay. For pump motor, I have used an indication, that is a bulb. Of course, I will show you that we can use the relay also. So let's go to our lab and check the live project. So now we are in our lab. So I'll just explain you the complete setup. What is the setup like? Then we will discuss about how does it work. Okay. So as you can see here, my solar panel, Then this side I have kept one charge controller, right? This is my charge controller PCB, which is going to the board. This is my ESP32, right? Your soil moisture sensor, DHT sensor, that is for temperature and humidity. And here I have LDR. I have used a simple LDR that is for light intensity. I have given connection to all these sensors and all through this 7805. Why? Because I'm using two batteries. That is approximately 3.7 plus 3.7. It will be 7.5 volts. So input is 7.5 volt. From here, I've taken it to, given it to the common area here. The plus and minus lines will be here. To that, from there, I've given it to this as well as to all the sensors. Here I have connected two light just for showing purpose. Like I have also used this, that is relay, but the load will be more. That's why I have taken out the relay. I will show you on this. This is my fan. That is, you can call it as an exhaust fan or blower fan. Okay. This side you can see, this is my pump motor. Okay. This is my small pump motor, what I have used it. And the sensor, that is soil moisture sensor, is going into the soil, which I have kept it in the small bowl. Okay. So how does it work? I will just tell you. So like all the connection I've explained, and you can check connection are very easy. Only thing is here also one thing is buzzer is also there. Okay. So I've given a buzzer also, which buzzer is also connected to the line. Okay. Which will give you some indications like, okay, right. Now, how does it work? Like when you go to your application, when it works, then you can see when the temperature goes high, naturally, if this thing like the temperature goes high, then your this will not start. That means now the motor has to start. It is now status on. It is showing status on. Okay. Now, if I put a little water in this, that is the soil, this light will go off. That means it doesn't require a motor. We automatically get switched off. Okay. Now, this both the things I can control it from my app also. This is my app which is there present. Okay. You can find two buttons over here, right? So I can control through these buttons and I can control. But please remember, I will show you on the LED part, okay, not on the motor part. Why? Because I'm not connected the motor. So like water pump and suppose it is on or off, I can control from my app. Okay, so I'm just showing you how you can control it from your app. So like app controlling, you can see here now. This here, there the light has come. That is, it is showing on. Okay, so I will just switch it off. It may take a little time. Okay, on. Okay, but it will come a little less. So same way I can control my fan also. So manual control, that is through the app, I can control both the things, as well as automatic control is also there. As you know, if the moisture level here comes down, automatically the motor starts. This is my motor. Okay, this is my motor. The motor automatically starts. And if the exhaust, the temperature is very high or the given under the threshold level, then the motor will start. Okay. Now, why the motor is not starting? Why, I will show you here. As you can see here, the temperature is 29. Okay. I have given a threshold of 30. 79 is the humidity. Soil moisture is 64. Light, like soil moisture is 64. That's why the motor is on. Okay. Okay. Then light level is 4095. Light, if the light level is very, very low, then if suppose I want to connect a bulb to inside the complete setup, then I can switch on that also. Okay. So these are the automatic your greenhouse control. Okay. Greenhouse control. So all the codes and all that I will be sharing after this, I will be sharing it and I will be showing it to you. I hope you like this project. I want that you should all try this project. This is a rough project. Please remember, this is a rough project. And as you are not able to hear the buzzer, why? Because the buzzer will give you some beeps for indication purpose. So all those things we can arrange in the codes. What are the codes over here? I will just explain you. You can see the this thing is going on there also. So I will just one by one, I will just tell you. So three libraries, that is the Wi-Fi, web server, and DHT. Since we are watching on the dashboard, so we need web server library also. Okay. So first we have to define the pins, what pins we have given here in the beginning. So that pins we are showing in the beginning first. After that, we will give the threshold values. Like threshold values we can change. That is dry soil, dry if it is less than 30, the pump on, and soil 20 is critical, that is the beep and all. Temperature is 28 degrees, fan on when it's less than that. Okay. sorry, more than that. So temperature critical 30 degrees, we have a humidity 30%, we have kept it, and LDR, we have kept it to 2000. Okay, right. So right now you can see on the bottom side, some values are coming since it is connected through my laptop. So I will just give you the complete idea. Before the again password, void setup, it will work on baud rate 1125200. Then pin out and fan out, buzzer out, pin in and buzzer in. All the in and out pins you have to give. Connection to Wi-Fi, as already we have discussed, delay time is 500, and it will be printed, IP address will be printed as you can see in the bottom screen, IP address. So it is printed on the screen only. Okay, the same IP address you have to copy and use it on the same network on other computer or your mobile phone. There, then stop alarm will be there. When what will happen? Then finally we come to the web dashboard. How it will be looking on the web dashboard. So this is very simple. We can change it. We can make the complete thing little different. Also, it's up to you what type of dashboard you want, HTML dashboard you want, and accordingly you will be selecting it. Okay. And finally, when it is all off, then it has to come to us.